Let's talk about 3.4, graphing linear equations in standard form.
22.
Thank you, Mrs. Potts. 22.
Handwritten 22.
You know I didn't write it. I would have been it's piece 3.4. It's page after the one we were on before. So, Andrew. So standard form is this: ax plus by equals c. Okay? So I want you guys to underline this. And here's the importance of this. We have been talking all about domain range, okay, and whether things are a function. But we haven't talked about how to graph them and how to give a representation of data, okay? So I've been giving it to you. I've been saying, oh, you know, you eat a piece of candy that has 50 calories, right? And like, what is your domain of that? Okay. And what is your range of that? Well, like, I've been telling you this and feeding you guys this, but just in reality, we've been preparing to graph it and create it so we can interpret and predict things using these lines. And the lines are used for all sorts of different things, okay? So long story short, the prediction of corona case viruses is pretty much represented by a exponential function, that curve, okay? Now, one of the things that I did when I got here and I was being interviewed was I actually took gas prices from the 1980s and I created a line using that. And I was able to predict the cost of gas. And like, I think my year that I was doing was 07. So I was able to predict the price of gas within like 2 or 3 cents using data from 1980. And that's what we're doing here is we're going to use some data and we are going to graph lines in standard form. But first things first, a solution of a linear equation in 2 variables is an ordered pair. That makes the equation true. So solution is a point on the line. So this is our line, and I want to know, is this point 25 on the line? So what I'm going to do is I'm going to first label my point. Okay? Label my point, and it's always alphabetical, X, Y. And next thing I'm going to do is I'm going to substitute. Jack, getting this? So I label, then I'm going to substitute. So I'm going to substitute in 2 for X and 5 for Y. And I'm asking, okay, I'm not saying is it equal, I'm asking, is that equal? And Sophia back there is like, yeah, 2 plus 5 is 7. So 7 equals 7. That's a check mark. So 2, 5 is a solution. Okay, meaning 2, 5 is a point on the line. Now in example 2, it's a little bit more complicated. Now I'm asking, is 2, 5 a solution to the line 2x minus 3y equals negative 11? So nothing changes. I still label it x, y, and I'm still going to substitute in 2 and 5 into this. So I have 2 times 2 minus 3 times 5. Now notice I'm just replacing the x and the y. That's why I did it in red. You okay with that, Matt? Now, when I go ahead and I substitute, okay, now I'm going to simplify. The last one didn't really have any simplifying. So 2 times 2 is 4. 3 times 5 is 15. So I'm asking, is 4 minus 15 equal to negative 11? And Neve just gave me the thumbs up. She said, yep, it is. All right, So this is true. So 2, 5, again, is a solution. Last but not least, we got 3, 2 here. Oh, we got another one. So this one, 3, 2, again, label it X, Y. And we have 2 times 3 plus 3 times 2. And I'm asking again, does that equal 12? And I think this was pretty easy to see. 2 times 3 is 6, plus 6. 6 plus 6 equals 12. So 12 equals 12. So again, 3, 2 is a solution. And again, all of these points would be points on this line or this line, the 2 that I'm given in the problem. All right, so for this guy, we're going to label it X, Y. I'm going to have 2 times 3 plus 4 times 2. And I'm asking, does that equal 10? 6 plus 8, does that equal 10? And the answer would be no, it's not. So this means that the point 3, 2 is not on my line and is not a solution. Jack, got all that?
Yeah.
You okay, Matt? Yep. Oh, no. All right, so Jake bought X pairs of thermal socks and Y shirts at the department store. He spent a total of $80. The following equation describes the relationship between the number of pairs of thermal socks and the number of shirts purchased. So 11X plus 18Y equals 80. And it says the ordered pair 4, 2 is the solution of the equation. What does 4, 2 represent? So this isn't really asking me to do much. It's asking me to understand the problem. So Nate, in this problem, I have a lot of information. I have that thermal socks cost $11 per pair. How do I know that? Well, 80 is talking about cost. It's talking about price. So 11 must also be talking about price because I'm simply going to do $11 times the number of socks that I purchased. And my shirts cost $18 a piece. So that's going to be 18 times the number of shirts. And that is going to have to add up to 80. So I have the cost of the shirts, the cost of the thermal socks, the cost of how much I spent. Now it's asking me, what does 4, 2 represent? Well, 4 represents X, which is, in my equation, pairs of thermal socks. And Y corresponds to shirts. So I didn't ask you to do anything. I just asked you to understand what the question is asking. So Sophie, ready for this? Awesome. So A says shirts cost 2 times as much as socks. That is false. Okay, guess we're not working now. Wow. All right, so shirts do not cost 2 times as much as socks. Socks cost $4. No, I told you socks cost $11. Jake spent $4 on socks and $2 on shirts. That's false. So the answer must be Jake purchased 4 pairs of socks and 2 pairs of shirts. Francisco purchased X hot dogs and Y hamburgers at a baseball game. He spent a total of $10. The equation below describes the relationship between the number of hot dogs and the number of hamburgers. This tells me, Liam, it tells me that hot dogs cost $3 each and hamburgers cost $4 each, and I spent a total of $10. So what does 2 and 1 represent? Well, 2 represents hot dogs. 1 represents hamburgers. So if I look at my answers, it says hamburgers cost 2 times as much as hot dogs. That's false. Francisco purchased 2 hot dogs and 1 hamburger. That is the 1. All right, now I'm going to just make sure that C and D aren't. C says hot dogs cost $2. Nope. Francisco spent $2 on hot dogs. Nope. And there we go. At the theater, Fred purchased X popcorns and Y drinks. He spent a total of $26. I think you know where we're going with this. Popcorn is X. Y, drinks. So my answer is going to be talking about 5 popcorns and 2 drinks. Look at that. Be a gun. All right, Jordan, apples cost 20 cents. Well, our oranges cost 30 cents. You spent $3.50 total on fruit. The equation 0.2x plus 0.3y equals 350 models the situation where x is the number of apples and y is the number of oranges. Which of the following is not a possible solution? Meaning, when I plug these numbers in, which one does not balance out the 350? So 1 apple means I'm going to do 20 cents times 1 plus 30 cents times 11. And I'm asking, does that equal 350? Andrew, can you type that one into your calculator? Just I. Let's go to Angela. I'm going to have you plug this one in. It's going to be 20 cents times 11 plus 1 times 30 cents. Angela, can you tell me if this equals 350? And then we're going to go with Mackenzie. Mackenzie, can you do this B down here, the red one? Should say C. So we bought 7 apples at 20 cents each and 7 oranges at 30 cents each. Mackenzie, can you tell me if this one equals 350? And last but not least, I would like to call on Jordan. Jordan, can you do 20 cents times 4 apples plus 30 cents times the 9 oranges? And can you tell me if that equals it? All right, Andrew. So did you get 3.50? Did you do 20 cents times 1?
Yeah.
So that's 20 cents, right? Did you do 30 cents times 11?
I didn't have to.
Do they add up? All right, so we're asking which one is not, so that's not my answer. Angela, what did you get for the green B?
2.50.
You got 2.50. Well, I guess that one's the answer. Because that one didn't work. Let's see. Who did I pick for this one? Mackenzie. Did you get 350?
Yeah.
Yep. So this was not it. And Jordan, did you get?
Yeah.
You got 350?
Yeah.
So that was not it. So there we go. It was the green one that didn't work out. Okay. Now to the fun part. We'll probably spend a good bit of time on graphing. So I want to introduce it today and just do 2 problems. Okay. So let me see if I can do this for you. All right. So we are going to graph using this method called the cover up method. Okay, it's what Mr. Beatty, I didn't come up with it. Mr. Beatty's so much smarter than me. Okay, Harshan, way smarter than me. He's the guy at the end of the hall, big, tall dude. All right, you might have him for geometry next year. Real smart. Okay, he came up with it and dubbed it the cover up method. So that's why I have my box there. Okay, so it says we are going to use intercepts, meaning the points where our lines cross the X and Y axis to graph these lines. Now, if we look at the diagram, it says the y-intercept is 0b, meaning x is 0 and y is a number. And then the x-intercept is a number comma 0, meaning the y is 0. Okay? So those 2 facts are very important, that for the y-intercept, x is 0, and for the x-intercept, y is 0, and we're going to use that. Okay? Now, I think you'll understand it more if I just get started. So I need a little bit more room to work. So I'm just going to rewrite my equation, the 2x plus 4y equals 12 over here. All right, here we go. We have 2 parts of my equation that I need. I need the x-intercept, which is where y is 0, and I need the y-intercept, and this is when x is 0. So here's what I'm going to do. Ready for this, Harshan? So simple, so don't miss it. See this? Okay, now you guys get to see here with me using my hand, okay? But at home, for the x-intercept, I will cover up y. Oh no, that's not going over top. Okay? So I will cover up the y. Do you see what's left, Harshan? 2x equals 12. So when I cover up the y, I'm left with 2x equals 12. So what does x equal? No, 2x equals 12. Would you agree 6, Harshan? That corresponds to the point 6, 0. Because remember, y was 0 right there. So I'm going to come out here on my axis, and I'm going to put a point at 6, 0. Y-intercept. I'm going to cover up the x. So I have 4y equals 12. What does y equal? Anybody? 3. So I have y equals 3. That corresponds to the point 0, 3, which is 3 on my y-axis. Now, to make a line, you need 2 points. Do I have 2 points? So, connect them. Okay, now Harshan, I've been doing this for many years. So, watch this. Ready? Oh, freehand. And I called my shot. That's pretty good, Harshan. Don't you? Did you use a straight edge? Real Harshan. Look, I'm not supposed to give you things. But you can use this as a straight edge. Just kidding. Somebody's got it. All right. You guys okay with that? Not bad? All right. Now, method number 2 says rewrite the equation by solving for y. We aren't going to do that right now. Don't cross it off. We're just doing this thing called the cover-up method right now. Okay? So at this point, we're going to stop. And